Hey guys, welcome to a new video. So YOLOv10 has just been released by Ultralytics. In this video here, we're going to see how we can set up the new YOLOv10 model. It's the newest family member in the YOLO family. So we're going to see how we can set it up with Ultralytics. We only need a few lines of code and then we can run object detection with the new YOLOv10 model. It is significantly faster compared to the YOLOv8 and also YOLOv9 model. I've done some comparisons here on the channel. You can go check those out, but also how you can train a custom model. So definitely check those videos out. So let's just jump straight into the Ultralytics documentation. If we go inside the models tab, again, you can go in and check all the documentation out. Everything will be in here. So let's go inside the model tab. We can see all the different YOLO members in the YOLO family, all the way from version 3 up until version 10. But also SAM with segment anything is covered in here. Mobile SAM, fast SAM, also YOLO NAS, real-time detection transformer, and also the YOLO world for open vocabulary object detection, where you can basically just prompt it what objects you want to detect. But let's now go inside the YOLOv10 tab. You can read about like the overview and also architecture, some of the key features, what are the changes compared to the other YOLO versions, and especially the YOLOv8 and also YOLOv9, which are based on the Ultralytics framework as well. So we have all these different model variants as we have with YOLOv8 as well. So we have the nano, small, medium, and then we also have a balanced version here, which both increases the width for higher accuracy, because one of the downsides with the YOLOv10 model is that they act like just get rid of the non-maximum suppression in the post-processing stage, where you act like just lose some accuracy there. So sometimes it is not good at detecting smaller objects, but if the model runs significantly faster, because we can get away from this non-maximum suppression at the end. So there's both advantages and disadvantages with these models. So definitely check out which of the ones performed best on your specific data set. So you can read about all of it here. Like we're going into details with it. We also have comparison here. We also did a real world comparison on different real life videos where we're detecting cars and so on highways. Here you can see all the comparisons with the other models, but let's scroll all the way down here to the bottom and take a look at the usage examples. So we only need to specify a few lines of code, which of the model that we want to use, and we're good to go. We can use Ultralytics directly. So first of all here, let's just go in and grab it. You can also train it on a custom data set. We have videos covering all of that, also inside the Ultralytics documentation, but also on my channel, how you can set up a whole computer vision pipeline, generate a data set, how you can capture images from a webcam, annotate it, export into Google Colab Notebook, train it in there on free GPUs, and we're pretty much good to go. I'll just grab this one here. Let's jump into a code editor. So I've just opened up Cursor. I've copy pasted the code snippet. We can paste it in directly here, but you can also run this from the command line. So if you want to run YOLOv8, for example, you can just swap it out here instead of YOLOv10. Then we can just specify YOLOv8, the nano model. You're good to go. And this is how easy it is to switch between these different object detection models with YOLOv8 from Ultralytics, or just Ultralytics in general. So right now here, YOLOv10, let's go with the small model. I'm just going to run this on my MacBook. Of course, you can also use a GPU. It will speed it up significantly faster. You can export and so on. So all the functionality is supported by Ultralytics, and we already have videos about that. So instead of the model here, we can go in and specify some other predictions. So we can just call the predict function. We specify a source. So right now, let's just have 0 for a webcam. And then we can throw in all the other different arguments. You can see those inside the Ultralytics documentation. So if you just go inside the modes tab up here at the top, and we go inside our predict method, if you scroll a bit further down, pretty much just all the way, we'll be able to see all the inference arguments. So these are arguments that you can put into the predict method that are just wrote inside our code editor. So right now we can specify save true, show if you want to use half precision, specify the image size and so on. So all of that can be specified in there. Right now, let's just go with some default values. So we're just going to save the video stream, and we also just want to show it live. So we can set show equal to true as well. And we might also be able to set our confidence here, because normally with the new YOLOv10 model, we need a lower confidence compared to some of the other ones. So let's just go with a confidence of 0.1 or probably just 0.15. Let's try with that and see what results we're getting. We just have a generate here returning all the results. We can extract the bounding boxes, confidence scores, class labels, and all of that directly from this results variable. This is just a pre-trained model on the Coco dataset. You have these 80 classes. We're good to go now. We can open up a new terminal window. Right now I'm just using Anaconda, Python, and YOLOv10. So this is the Python script, YOLOv10.py. There we go. I'm now going to run it. Should open up the webcam and we should see the live webcam stream running object detection with the new YOLOv10 model. So I just missed a very important point here. It was not because of my webcam. We basically just need to upgrade Ultralytics, so I even forgot that. But you might run into this problem. Will be the most common problem. You guys are probably going to like throw down in the comment section as well. But we need to upgrade our Ultralytics package. So if you just pip install Ultralytics, upgrade with pip, we should be able to get the newest version. It will take care of all of it, and then version 10 should be supported. So there we go. Now we can see that has upgraded from 8.1 to 8.2. So now let's go in and see if we can run the Python script again. I've changed the webcam back, and now we should be able to open it up. So we're downloading the YOLOv10 model here automatically. So right now we know that we're on the correct version. So now we just need to make sure that we have the correct webcam. So download the model automatically, it will do all of that. You can also specify your own model that you want to use. So if you're training a custom one from scratch, you can just specify the path to it up here instead of the pre-trained models. So now we can see that the stream is up and running. It is running rather slow. This is just running on my MacBook CPU. We can speed it up significantly if we're using a GPU. I also have a 4090 RTX graphic card from NVIDIA where it runs around like 10 times faster. If you go in here, we can see the inference speed is around 180 milliseconds per frame. And if you're using the CPU, I'm probably getting like 200, 250 milliseconds inference. So it is faster compared to the YOLOv8 model, especially also on GPU and if you do optimizations and so on. But you can see that directly from the comparisons tables and also the comparisons that I've done here on the channel. So it's pretty much just, it's detecting this as a hairdryer cell phone sometimes, but we also have low confidence scores. The person here, again, we can move around. We see all the detections. Let me pull up my phone. There we go. Cell phone. Pretty much just get that right away. Watch a clock here. We can see that the clock here is also in the Coco data set. Then one of the downside with the YOLOv10 model is that they're getting rid of the non-maximal suppression layer. So we lose some accuracy. We need lower confidence score. We will get some false predictions here and there, but it runs significantly faster. So it really depends on your applications and projects that you want to run. Which of the models are the best? Definitely test it out. If you should use like YOLOv9, YOLOv8, YOLOv10, do we need the best accuracy? Do we need the best performance? You can also take this model here and do tiling windows with Satya and so on, where you basically just have a window sliding over the whole image, doing inference. You can run faster, but again, it will take multiple iterations. So it really depends on your project applications. We have it up and running now. If you want to run tracking, you can also do that on top of it directly. So let me just terminate the program. Instead of calling predict, we can also just call track. And it will basically just track all the objects in the frame. Instead of just doing predictions on each individual frame, we will now track it over a number of frames. And now we can see that we also assign an ID to each of these objects that we're detecting. So ID 1 here, even though I'm moving around, it should still be able to keep track of me. I'm looking away. I can even like move a lot in the frame and I still have ID 1. Even though I go out of the frame and come in again, it should still be able to pick me up, which it does with reidentification. So you can see it just lost like 1 frame or so with detection of me. Okay, so that was like fairly long that it lost me as a detection, and we still got back to ID 1. You can take up like any object. You can do object counting and so on with object tracking on top of it. Now we can see that it lost track. Let's try to see if we get ID 10 again. ID 11. Let's just turn it around. It might be easier from the backside. ID 11, 13, so here it switches a bit back and forth, but it depends on the tracker. There's multiple different trackers available with Ultralytics. So this is how you can run the YOLOv10 models, the new models in the family. We can also just try with the nano model. If you want even better performance, you can go with the large, extra large, and so on. But again, this is how easy it is to run. A few lines of code, you can extract all the information. Now we can see that it runs significantly faster. If you go in here, around 100 milliseconds, so that's 10 frames per second, and it's running object tracking on top of it as well. You're going to extract all the results here. We have videos of that. You can also check it from the Ultralytics documentation, how we can use it in your own applications and projects. So thanks a lot for watching this video here, guys. I hope you have learned a ton. Definitely going to check out the new YOLOv10 model. Try to do comparisons on your own data sets. If you used some YOLO models in the past, try it out on the new YOLOv10 model. Also, if you need a bit of boost on the speed side, YOLOv10 might be the better option to go for, but there's no correct answer. Doesn't matter like what data set you have. You need to do some testing, some iterations back and forth, and test it out on your own data. Thank you guys for watching this video here. I hope to see you guys in one of the upcoming ones. Until then, Happy learning. If you want to get into an AI career, you should definitely check out my AI career program. The program is basically all my experiences from how I went from an average student to where I am today. The program consists of 3 main categories. We have my technical courses, my personal branding course, and then the AI career path. We have a whole community in there with like-minded people supporting each other, and every week we will have weekly live calls where I support and help all of you guys. Over time, more courses, resources, code templates, and so on will be added to the program. You will give lifetime access. So the sooner you join, the more value you will get for your money. Let me help you take your AI career to the next levels.